Hi there, my name's Kate Marshall and I work as a DevOps engineer and technology consultant at IBM. In this video, I'm going to introduce some central concepts such as containers and container orchestration platforms, which are key to understanding some of the most popular tools in a DevOps world. I'm then going to answer the question, what is Red Hat OpenShift? So let's get started. In order to understand what Red Hat OpenShift is and the role that it plays in a modern DevOps landscape, we're going to first introduce some fundamental DevOps concepts. The aim in going through this exercise is to first understand what is a container orchestration platform, of which Red Hat OpenShift is one of the most advanced and modern offerings on the market. So let's break this term down into sizable chunks and first talk about containers. A container is a lightweight standalone package of software. It's an executable software package that in fact contains everything needed for an application to run. Let's think about this as in going away on holiday and packing a suitcase big enough so that we would survive for some indefinite period of time wherever in the globe we wanted to go. We would need clothes for every climate, food to last you a wee while, etc. Your case would get pretty big pretty quickly, or it would for me at least. And the same concept applies when we're thinking about application container images. To accomplish a fully containerized application image, the container must hold within it all of its dependencies, application and system libraries, the operating system, and application source code to be executed at runtime. The result is a ready-to-go portable container image, which is often stored or hosted in a public or private container library or registry, so that peers and colleagues quite literally push or pull versions of this container to run on their local machines. By allowing the porting of this packaged software, we remove the famous complaint or concept of, hey, it doesn't work on my machine. The package itself comes with an operating system and dependencies of its own, so you only need to have the means to execute the container in order to run an application on any PC, wherever you are in the world. So quite literally, all you need is internet access to pull the image off of some centralized registry or library, and a command line interface to run it. Some features to note about containers include immutability. Their immutable nature means that once the code is packaged and published to some central registry, you cannot alter the source code within that container without publishing a new version. Containers come with several possible runtimes, which we can think of as like brands. Each brand will offer you a slightly different way of running these containers, with different benefits associated to security and other factors, for example. Some of the most popular brands or container runtimes include Docker, Cryo, and Podman. Let's move on to the next piece of our puzzle in understanding what container orchestration platform means. The word orchestration suggests something like we should be thinking of coordinating some number of instruments or moving parts, which is of course quite right. In our context, these living, breathing, moving parts are our containerized applications, or even more likely, multiple microservices making up one complex application. This intelligent coordination or orchestration manages the lifecycle of various pods, deployments, services, and other YAML-specified resources that make up the organs of our cloud-native, distributed microservice architected application. I just said a lot of words, and things like pods and deployments might be new to you right now. But for now, just think of these as resource types or different types of files that are intelligent enough to pull and execute our container images so that our application can really come to life. Finally, let's look at the word platform to complete our analogy. There are a number of platform offerings with intelligent container lifecycle management capabilities. This is usually carried out by implementing resource types such as pods and deployments that we mentioned before, although these terms and implementations may change depending on the platform you choose. Each of the major cloud providers, for example, will probably offer some container orchestration or management services, such as AWS Cloud offering Elastic Container Services, or ECS for short. Docker itself offers Docker Swarm, which occupies much of the same ecological niche. One of the most widely used container orchestration platform offerings on the market is the open source Kubernetes project. Kubernetes is a highly mature and widely adopted platform for managing containerized workloads, born out of an open source Google project in 2014. Kubernetes has been built on years of experience of running production workloads at scale by an extensive global but pretty friendly community of DevOps enthusiasts. So that introduction to some fundamental DevOps concepts like containers and container orchestration platforms leads us nicely into the big question of this video. What is Red Hat OpenShift all about? Let's give it a go. OpenShift Container Platform is Red Hat's industrialized version of Kubernetes. Red Hat is a pretty big, fancy, famous software company that is well known in the game of providing open source enterprise software products. So there was really no one better placed in revolutionizing the DevOps world with a new take on Kubernetes cluster management. OpenShift was, of course, built with containerization and Kubernetes concepts as a core focus, but offers value over and above Kubernetes by wrapping the platform in a developer-centric user interface. OpenShift is an alternative to Kubernetes cluster management for developing and hosting enterprise-grade applications with the added bonus of enterprise-grade support. OpenShift brings to the table operational and developer-centric tools that facilitate accelerated application development and lifecycle management. One of these offerings is that of Red Hat Operators, which we will discuss in a little bit. However, the first step to achieving developer control over OpenShift-hosted containerized applications was revolutionizing the dashboard's role in the management of cluster environments. Kubernetes relies heavily on DevOps engineers being comfortable using the command line interface to interact with its pod, deployment, and service resources, which are hosted internally within our cluster and actively running our containerized applications. Of course, Kubernetes does offer a dashboard, but the OpenShift dashboard takes us to the next level. Here we can see a user-centric and entirely interactive view of our cluster workloads, networking configurations, as well as out-of-the-box Red Hat operators. What are operators, you might ask? Operators are software extensions to Kubernetes that make use of custom resources to manage applications and their components. Operators follow Kubernetes principles such as the controller concept and the control loop, and essentially perform as custom controllers that make it really easy to package, deploy, integrate, and manage various Kubernetes native applications. We can see a few of these operators by opening up the OpenShift Operator Hub. You might recognize a few of the more well-known applications that are supported as operators in OpenShift. Let's talk a little bit more about why OpenShift was so important to transforming the DevOps and cloud application landscape. OpenShift is key to the hybrid cloud movement, which is being adopted by many big industry players across the globe. This means that consumers are using multiple cloud platforms for different scenarios to meet their needs. OpenShift integrates effortlessly with major cloud vendors because it sits as a layer on top of the vendor platform. Many of these cloud providers also now offer managed support with OpenShift clusters. The benefit this common layer brings across all cloud vendors is a standardization in managing containerized applications across these platforms. The correct term for this is that OpenShift offers a cloud-agnostic solution to cloud application development and hosting. Think of a family where everyone has different dietary requirements and has to eat from a different loaf of bread, like wholemeal or gluten-free, white or brown. But you only need to buy one pod of strawberry jam or peanut butter, whatever's to your taste, to go on each of these slices of toast. The spread goes nicely on whichever loaf you choose, and everyone's eating jam on toast for breakfast at the end of the day. This is a bit of a silly idea, but the value I really want to highlight is that no matter the cloud platform, by promoting consistency in application hosting, we accelerate the cloud-centric application development lifecycle. We don't need a specialized team to manage each application or microservice dependent on the cloud platform. In fact, the developers themselves are empowered to manage their applications without needing to give much thought at all to what's going on underneath that OpenShift dashboard. And that's pretty cool. OpenShift actually offers more benefits than what I've just mentioned here, such as improved security and patch installation and support. But we can leave that exciting nitty-gritty for another video. So what have we covered today? We've spoken about containers and we've spoken about the components that are needed to understand what a container orchestration platform is. We've looked at a few examples of these, like Kubernetes, and finally we moved on to OpenShift. OpenShift is the brand new industry standard for container orchestration platform in the modern DevOps world. OpenShift was really exciting because it offered a standardized way to manage cloud applications no matter the cloud vendor underneath the OpenShift dashboard. It was also really exciting because it empowers developers for the first time to manage their own containerized workloads that make up the applications they're of course developing. We also had a look at what an OpenShift dashboard looks like and spoke really briefly about operators, which are a really exciting addition to the DevOps toolbox. Thank you so much for listening, and I hope you'd like to tune in to another video soon. See you!